Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 29 of NEET physics paper 2017. Students, let us solve question number 29. The question says an arrangement of three parallel straight wires placed perpendicular to the plane of paper carrying same current I along the same direction is shown in figure. So basically this is the plane of the paper. We have got three conductors placed perpendicular to the plane. One is here, another is here, and the third one is here. One, this is the second one, and this is the third one. So in this fashion, it is represented with a dot over here. This dot represents the conductors. So let me just draw the diagram. One conductor is here like this, another conductor is here like this, and third one is here like this. So there are three conductors in the plane and perpendicular to the plane. And all of these are current in the same direction. This dot means the current is in upward direction out of the paper. So in this conductor the current is up, that also conductor is current is up, and in the third one the current is also in the upward directions, and that current value is I. Current is I along the same direction as one. Magnitude of force per unit length you define. So you define the force acting per unit length on the middle wire B. Means this is B as shown in figure. This is B. This conductor is named as A, and this is conductor C. So you to find the force per unit length on this conductor B. So this is for B, you have to find the force per unit length is given by how much is that force per unit length. These conductors are supposed to be infinite long, very very long. So if I have a conductor B here, and I have another conductor at a distance say D here, so the distance is D here, this distance is D, this distance is also D. So I have one conductor over here, which is the separation between the two conductors is D. So this is the case. We know that when we have two parallel conductors placed side by side, and the currents are in the same directions, they attract each other. So the force on this B due to this one conductor C will be attractive in nature, so the force will be toward this side. This is the force on B conductor due to C. Similarly, the force on B due to this A conductor, because the current is pointing in the same direction, so this will also be attractive, so it will pull towards itself. So this is the force on B due to conductor A. So in resultant, these are the two forces acting, and these two forces will give a resultant force. Somewhere like that. This is the B net, sorry, F net. This is the force net. Alright, this is the force net force, B net. Alright, this is the net force. You can also find net B, but then we're interested in net force because magnitude of force per unit length. So it is net force per unit length to find. Okay. So to find the net force, we will use the parallelogram law of vector addition, and these two forces are separately found. And obviously one more thing is that these two forces are equal. Okay, these two forces will be equal. In terms of direction, they are not equal. In terms of magnitude, they are equal. So if two vectors are equal in magnitude, and they make an angle of 90 degree, so the resultant will be magnitude wise it is root 2 times the individual one, either BC or BC or AB, because that is how it is done. Okay, why this is done that we'll discuss later on, but then first of all let us write that. Or if you want, then I will just let me tell you how this is done. If two vectors, suppose the vector is having force F and this vector is having force F, two forces acting perpendicular to each other, so theta is 90, then the resultant is given by, this resultant is given by F net is F square plus F square plus 2 product of F and cos of 90 root. This is how, this is the parallelism law of vector addition. So this is 0, so this is 2f square root, which is under root 2f. So therefore I wrote that this is root 2 times the any one of the forces because the magnitude is same. Now we are interested in FBC, that is force on the conductor B due to C will be given by, we know that if there are two parallel conductors carrying current I or I1 or I2, I can take, it is not necessary that the current will be same, but in this case the current is same and the distance of separation is suppose x. Then the force on any conductor, force per unit length, is given by mu 0 upon 4 pi 2 I1 I2 divided by x. This is the force acting per unit length. So if this is the case, this is the force per unit length acting between two parallel conductors. So because the B is here and C is here, they are just like two parallel conductors like this, and the distance separation is d. Current in this case is I and I. So therefore I write BC is mu 0 upon 4 pi 2 product of the currents. The current is same, so it is I square divided by the distance, that is d. If I cancel this one, then this is mu 0 I square upon 2 pi d. 2 will cancel and 2 pi d. I am not interested in direction because the answer is given in terms of the magnitude. Otherwise I should have taken this as I cap and this I should have taken as minus j cap. So in vector form if you want to write, but it's not required, then it is mu 0 upon 2 pi d I square and this is I cap. Okay, the force will be towards that side. Okay, IL cross B, so it is that side. And similarly the force on B due to conductor A is also this one, mu 0 upon 2 pi I square upon d minus j cap in vector form. But you take the magnitude, then it is always this one. So we have got the magnitude of these two forces, so resultant will be root 2 times this value, because resultant is root 2 times this value. So the resultant of FBC and FBA is root 2 times any one force. Obviously I am finding the magnitude of the resultant, and that is root 2 times any one of the forces like this one, mu 0 upon 2 pi d, and this is I square. This root 2 will cancel out and one root 2 will be left here, so it is mu 0 I square upon root 2 pi d. So this is the resultant force I am getting, and in fact that is the answer, because we don't want anything else. You can see that this is the answer. You can see here, mu 0 I square root 2 pi d, mu 0 I square root 2 pi d. So option number 4 is the right answer to this question. Okay, thank you.